Good evening, everyone. My name is Anna, and I want to introduce Team NeuPro with our customer Thomas, our project lead Sajid, and 5 developers, Felix, Maria, Jonas, Yannick, and Jonas. Together, they built an amazing prototype in the last few months, and they would like to demonstrate it. Please enjoy.
So, hello, welcome everybody. We are Team NeuPro, and we would like to show you our achievements. So, our problem was actually dirty boats and damaged yachts. More specifically, we are interested in the cleaning process behind it. So this involves manual work, toxic chemicals, and it consumes a lot of time. So we would like to improve this process and automatize it. So how we are going to do it is I will guide you through the workflow and simultaneously introduce you to our setup. So, as you might see, this is our car door. It is dirty, so you're going to see that later on. So it has a mud point and also a leaf. Unfortunately, we cannot bring our yacht into the lecture hall because it's too small. Well, so, and then we have also our background guys, which are on the server, and this is our main actor, the Dirt Buster. Okay, so now the workflow. So as you can see, this is a camera, and this camera is taking 2 kinds of images. One is a 2D image, and the other one is a 3D image. Then we are processing the 2D image with instant segmentation. So we are figuring out the dirty and damaged spots, and also the surface material. Then we use the 3D image to calculate 3D coordinates. Then we are combining those detections in a plan and figuring out a work plan. Then we're sending this work plan to our app and display it on our app, and then the user is able to edit the plan or to approve it. If he approves it, we're sending the work plan to the robotic arm, and then it is executing the work plan. Now, Maria, could you please introduce us to the app?
So, hello everybody. So, when starting our app, you come to a nice overview screen which has some information for our user. Underneath, you have here the Start Project button, so let's click Start. Now the robot moves in the camera position to take a photo of our car door, and you can see that the work plan is creating. This will take about 20 seconds. Meanwhile, Jonas and Felix will introduce the background behind it.
Oh, hello. All right. And now I'm going to tell you a little bit about machine learning magic, what is happening in the back. So we need a training set. And in this training set, this is like one sample out of the training set. We are labeling our sample and highlighting the dirt with a polygon. We do that several times, and then we have a huge training set. This training set is then used for the machine learning model in order to train it. Now we're going to check out if it's working. So we are feeding our machine learning model with this random picture, and then we receive this result. So as expected, we have the dirt in the very middle, and also reflections, which were a major challenge during the data collection phase. All right, now Jonas will tell us a little bit about the path planning. There you go, buddy.
So thank you, Felix. So for the path planning, our basis for that is our 3D data, which we get from our stereo camera here on top of the robot. And you see it here represented as a depth image. And the first thing we do is we convert it to a 3D point cloud, which are basically just a bunch of points in 3D space. Here it looks a little bit more like a surface rather than individual points, and that is because these are quite a lot of points. So to speed up the processing, we reduce the points by only taking each 10th point. So now we have our point cloud, but as you see, we not only have the car door, we only have some points from the background, and they are rather disturbing for the path planning, and we want to get rid of them. So we get rid of them by assigning each of the points to a cluster. So all points that are nearby each other get assigned to the same cluster. You see these clusters here represented as these colored clusters. Yeah. And now we select the cluster which is closest to the camera, and then we only have our car door. So the biggest challenge with this point cloud was that the surface wasn't that flat. It was rather bumpy and irregular. So to compensate for that, we did a smoothing step. The result you can see here. So on the top, you see the point cloud before the smoothing, and on the bottom, you see the smoothed version. And that is also very important for our next step, because then we calculate surface normals. You can see that here. So these lines, every line represents one normal for one point of the point cloud. And we need these to determine how we have to place our tool on the surface, because the tool always has to be perpendicular to the surface, and with these normals we can calculate the rotation to achieve this. So now we have all the data to really start our path planning, and we begin with our 2D image. You can see it here on the right side. It's you can see here some dirt and the machine learning prediction, this red bounding box. And into that bounding box, we insert a 2D path, which are just a bunch of points. And then these points we project into 3D and search in the point cloud for the closest point to this projected point. So now we have our first point for our 3D path, which can then be executed by our robot. And we do this for all the points. So now all these things happened in the background. And Maria is going to show you what happens next.
So now you can see a nice overview screen, which was calculated. Above you have the material, metal was detected, dirt and damages were found. So let's look at the dirt. You can see mud was detected here, and also the leaf. If we want, we can also add a box and change the size, but this isn't needed in our case. So let's go back. Also, because we want to clean our car door, the tool is brush. And now we can approve or decline the workflow. So let's approve that. Now you come to this view. Above, the progress bar and the 2D and 3D buttons. Clicking 2D, you see all the annotations. So you can see damage, the yellow boxes were detected, and dirt, the red ones. Also, you have here some notifications that the robotic arm is ready and the work plan was successfully created. So let's start the progress. Now you can see the robot starts moving towards the mud. He is cleaning properly. The progress bar is changing. We are now at 25%. He is cleaning constantly and doing the mud spot. We are at the half of the progress, still cleaning the first box. And it looks pretty well from my side. So he goes back, and he will go towards the leaf again and cleans it off. So now the progress is done, and you can see a pretty nice car door. So I hand over to Felix again.
So now I'm going to tell you a little bit what we did since the design review. So for the cleaning controller, we already had the material detection, we had the 3D surface detection, and now we can also detect dirts and damages, and we can do the path planning for our robotic arm. For the app, we already had a work plan overview, and we could already display 2D and 3D images. And now if the user presses start or stop, that gets sent to the robotic arm, and he acts accordingly. The robotic arm wasn't really included yet in during the design review, but now he can, as you saw, execute the work plan and start and stop if the user presses start and stop. There's one thing left which we have to work on. So if the user changes these annotations in the app, the robotic arm doesn't yet react to it. And we also thought about some things which we could implement in the future. So we thought about integrating a database to make the storage more persistent. We want to visualize our path in the app and use push notifications. we want to allow multiple tools for the robot, so not only a brush, and we want to put the robot onto our mobile platform and use a force sensor to detect when the robot touches the surface. So, yeah, we want to thank Thomas for providing us with this great project and providing us always with help. So thank you, Thomas. Yeah, thank you.
I have to thank you for your fantastic and great work you made and the time you spent on this project. And I think it was a very good collaboration with you. Thank you.